Hi there, welcome to your lesson on cumulative frequency. The word cumulative comes from the word accumulate, and clearly that's what we can see here, something accumulating. Alright, so our goal today is to create and apply cumulative frequency curves. Here's an example of a cumulative frequency curve. And always on the y-axis, or the dependent axis, for this kind of curve, we will have our cumulative frequency. And on the x-axis or independent axis, we will have the variable, the data set that we have. These curves show how data in a data set accumulates. So we can see how this data here is accumulating over time, not over time, sorry, accumulating as we get further into the data set. Let's take a look. So here's how we're going to do this. Consider the frequency table below, right here, which shows the number of students who have lost a certain number of pencils. So, for example, 8 students have lost 5 pencils, and 6 students have lost 7 pencils, and 3 students have lost 10 pencils. So you can see not many students have lost 0 pencils, or 1 or 2, but as you get to 3, 4, 5, 6, 7, in that middle number of pencils lost, there's more students, and then it decreases again. So low frequency, higher frequency, low frequency. And that's what we can see on here, because this is a cumulative frequency curve. So what happens here is it shows us what happens as we add these numbers up. So let's see. I'm going to show you that first point is 0, 1. That matches this. However, the next point on here is 1, 2. That does not match our point here. So where does that 1, 2 come from? And now look at the next point, 2, 4. Again, that does not match what we have here. Next point is 3, 9. Next point is 4, 15, and on and on. Those points clearly do not match what we have here. However, they match what I'm showing here now. Look, 0, 1 is here, 1, 2 here, 2, 4 here, 3, 9, and then 4, 15, and on and on. So what does this column represent? What's going on? How did we get at these numbers in this column? What do you think? Well, those numbers are what is called a cumulative frequency. We take our frequency numbers and we accumulate them. So here, the total of frequencies is 1. But now, as we go to 1 pencil lost, now we have a cumulative frequency of 2. If you add those, you have 2. And now when you go to the next one, and you're adding an extra 2 in the frequency, so now you have a total of 1, 2, 3, 4, here, 4. And when you go to here, now your total of all your frequencies, all these numbers here, is 9. So cumulative frequency is just a count when you take your previous amount and add the new. So here we have 9, we're going to add 6 to it, now we have 15. We have 15, now we're going to add 8 more frequencies, or 8 more counts, and we have 23. So this is a total column for your frequencies. So by the time you get to the bottom, the 50 represents the total amount of data you had. For example, if you added all these frequencies up and made a column below here, or a row below here, that shows your total number of data points, it would be 50. And that's what this shows. This is like a running total. Okay, so that's cumulative frequency. So now if we take those points, we can make our curve. So the curve shows how we accumulate frequencies. In the beginning, like we said, the frequencies were going up in small amounts. And then all of a sudden the frequency amounts, this was higher frequency here, and then lower again. So look, slow accumulation of frequencies, quicker slope means faster accumulation of frequencies. You're adding more frequencies, and then up at the top it slows down again. So that's what the cumulative frequency curve shows us. Second question for you. Why will the cumulative frequency graph never curve down or left? Okay, so the answer to that is, well, if it went down, if it curved down, that would mean that you're losing frequency values. That means that somehow, as you're going further in your data set, you're taking away frequencies, like you're saying you have negative frequency values, but you can't have that. You can only have positive frequency values or 0, right? Okay, why will it never curve left? Why will this never turn back and go left? Because we're just moving through the data table here, and we're moving further into our possible data values for the variable, so that's why it goes in that direction. Okay, so let's look at how to create one from scratch. We just created a cumulative frequency curve for ungrouped frequency data like this. More typically, however, cumulative frequency curves are made for grouped frequency data, such as this. This shows discrete data, this shows continuous data. So again, usually we make cumulative frequency curves for continuous data. So you can see now there's a there's a range of values that we can take here, rather than just 0 pencils, 1, 2, 3, and you cannot have a number in between. Here we can have every possible number. So here's some time, measurement of time of something. We don't know what, but the time can be between 3 and 4, and then 4 and 5, and so on and so on. And we can see our frequency of each of those possible times here. Okay, so notice again, these are grouped frequency tables. So what this situation represented is this: 50 contestants playing a game called Oware. This is an old African game. In total, they have to play 49 games to arrive at a champion. Their average times for the 49 games are given in this table. Okay, so that's what these times represent, the average time it took to play one game. So for example, we can see there was only 2 games that were played between 3 and 4 minutes, but 12 games that took 4 to 5 minutes, 18 games took 5 to 6 minutes, and so on and so on. And then very few games took more than 7 minutes, let's say. Okay, so here's how we set up our cumulative frequency. Okay, first thing we need to do is set up what's called an upper boundary. Since we have a range of possible times here, when we go to plot the point, we don't know. Are we going to use a value of 3 or 3.5 or 4? What value are we going to plot? Well, the one for cumulative frequency, we always use the upper value here. So if we see a 4 here, that's called our upper boundary. So here it's 5. What will the next upper boundary be? Well, clearly that's 6. Okay, and then we have our cumulative frequency column. So again, that's the column where we're accumulating the frequency values. So in the beginning, there's a total of 2. And then we add 12. So now the total is 14. Okay, so what's the next total here? How much are we adding now? Well, it's 32 because we added 18. Okay, let's keep going. Fill in a couple more rows here. 7 and 43, 8 and 46, 9 and 48, and 10 and 49. Check yours carefully. Again, by the end, the cumulative frequency column should get to our total number of data. And in this case, we were told there's 49 games. And again, if we added all the frequencies, we would get 49. And that's what we see this reaching here, because it's a total, a running total. Okay, great. So now we have upper boundaries and cumulative frequency. We're going to use those. There's the upper boundaries. And we're going to use the upper boundaries and cumulative frequencies to graph. So first point we have is 4, 2. 4, 2 is here. Next point we have is 5, 14, right? 5, 14. Plot that point here. Keep going. What's the next one? 6, 32, 7, 43, 8, 46, 9, 48, and 10, 49. Notice it has that shape we saw in the last one. Something like that. That is our cumulative frequency curve. This is not perfect. This should be above 0 here for sure. But anyway, you get the idea. So you can see a slow accumulation, then rapid accumulation, and then slow. Again, the reason is we have very few frequencies here in the beginning, and then a lot. So it quickly accumulates frequencies and then slows down again here. We can see slows down. All right, that's how it works. And it should reach an upper limit of 49. It should always reach that upper limit of our data, the total of our data set, 49. Okay, so now let's check your understanding. Here's a cumulative frequency table, or a frequency table, and it has a cumulative frequency column. We can see the graph provided here for this cumulative frequency. So using the graph and using the numbers you see here, let's figure out what A is. What's A? Okay, not just A. Find the values of A through G, all of them. All of them, all right? And notice that they are going in strange order. A and B is here, then C. The reason for that is because I think it would be easier to calculate B first, and then C, and then D, and then E, and like that. So go ahead, go through that table. Use this, use the table. Let's see what you can come up with. Okay, so now check your work on all those. There's all the answers for those. Hopefully that went okay for you. Let's take a look at a few just to get us started. We can see cumulative frequency is 3, and then the next cumulative frequency is 7. Therefore, we know that a frequency of 4 has to be here because we had to add 4 to get to this next value. Okay, then we add 6 to get 13. Then we, what's going on here? Okay, we have a B here. Well, we don't have any values after, so we can't do it. But we can look at the table then, right? So look at the upper boundary of 50. Okay, so upper boundary of 50 here. I'm going to go up here, and I can see it's a value of 20. So that point at up has to be a cumulative frequency value of 20. So if B is 20, then we know we had to add 7 to 13 to get 20. So this is 20, and this is 7. Let's do this one the same way. Now we've arrived at 55 as our upper boundary. So I go to 55 here, and then I go over here, and it's 28. All right, so that means this must be 28. Therefore, if the last one was 20, this had to be 8, so we can get from 20 to 28. Okay, on and on, it goes that way. Great job if you were able to figure that out. Okay, so let's check our understanding. Starting at this frequency table, draw a cumulative frequency graph for it, okay? So this represents the number of parked cars per hour, I guess, maybe in a parking lot. So there were 0 to 49 cars. That happened 6 times. Or 50 to 99 cars. That happened 23 times. All right, and so on and so on. So now, make a cumulative frequency column, figure out the upper boundary, and then see if you can make the graph. Okay, in this case, I'll just give you a hint. The upper boundary, since, look at this goes 0 to 49, and this starts at 50. This is different what we had in the last one. In the last one, we had greater than or less than symbols, and one of the ranges went to a number and the other one began at that same number, right? But here, there's a little gap between them, so we have to do upper boundary as the number right in between each of those. Okay, so now do the cumulative frequency column and then sketch your curve. Okay, here's cumulative frequency, check your numbers there, and then the curve will look something like this. So I checked if you had that curve by asking a simple question about one location, and you can now confirm that it is on that curve. All right, great, awesome. So now let's talk about quartiles and cumulative frequency. So when we have a cumulative frequency curve, we can go back to the idea of quartiles that we looked at in our last lesson. So we know a median is the middle data point in a data set. So let's say, in this case, remember cumulative frequency shows us how much data we have. So in this case, we can see we have 100 pieces of data because this goes all the way to 100. So if we had 100, well, it's easy to say where the position of the median is. It's the 50th data point. If this was not 100, you would have to do 0.5 times whatever number of data you have, right? But anyway, in this case, it's 50. So our median lies there. We can go from the 50th data point, because this represents our data points, 50th data point, go to the curve, find that point, drop down, and that tells you that, in this case, I guess this is showing grades in some class, 60% was the median grade in that class. Okay, lower quartile was the point at which you're 25% of the way through the data, right? So here is 25% of the way through this data set, because 25 is 25% of 100. So we're 25% of the way through the data. We go across to the cumulative frequency curve, then we go down, and we can say, okay, looks like 45% was a Q1 or quartile 1 grade in this class. And finally, upper quartile is 75% of the way through the data. So we go up to 75 in this data set, go across, go down, and now we have arrived at a mark of 70%, which is your third quartile value. Okay, again, total data here, 100. 25th position in the data set is Q1. 50th position in the data set is median, and 75th position in the data set is upper quartile. We can see them here. Okay, so now looking at this one, I want you to think about looking back at our data set we had about the time playing that game, right? So we had a upper bound, and the question is, what's the median, right? We remember we had a total data set there of 49 data points. So what's our median here, based on what we just talked about? Okay, to find the median, we need to do 49 data points divided by 2, or 0.5 times 49, right? Which tells us at the 24.5th data point, that is our median. So 24.5th, you're going to go here on your data set. 24.5 is about there. Go down from there, and that means our median is about 5.5 minutes. So our median time to play that Owara game was about 5.5 minutes from the cumulative frequency curve. Okay, next question. What about the Q1 value? What's the quartile 1 value for this? In other words, what's the quartile 1, the time it took to play the game in the first quartile? Okay, for this one, we're going again, the total data set is 49. To find Q1, remember we have to do 49 divided by 4. Because it's 1/4 of the way through the data set. Or you can alternatively do 0.25 times 49, right? So the 12.25th data value is the quartile 1 data value. So here I put 12.25, then I go down, and that seems to represent about 4.85 minutes is our Q1 value for this data set. Finally, of course, we're going to look at Q3, so try this one. Okay, for Q3, our total data again is 49. For Q3, notice what I'm doing here, 3 over 4. It's 3/4 of 49. Alternatively, you could have done 0.75 times 49, right? So that's right here. We drop it down, and we get 6.4. Okay, let's practice a little bit. Here we have a situation with a group of 80 athletes, which each run laps of a running track. The group's frequency table shows the number of laps run by different athletes. For example, 0 to 10 laps were run by one athlete, and 10 to 20 laps were run by 20, and so on. Okay, so construct a cumulative frequency table. Once you have that, from the table, acquire a median, a Q1 value, a Q3 value, in order to be able to find the interquartile range. So try that now. Okay, here is your cumulative frequency table. So here's the cumulative frequencies. We can see here it adds up, it sums up to the 80 athletes in total here. And then there's what the graph should look like roughly. Our Q1 value, median 26, Q1 34, Q1 20, Q3 34, and then IQR 14. Okay, one important note. When you're using cumulative frequency graphs, there's a little bit of approximation going on there, right? Because you might not find the exact value here, right? And that's okay, that's part of it, because we're trying to gather values from this graph, and that's not always completely accurate. For example, if we found the median using our normal n plus 1 over 2 formula for the position, or if we just did n over 2, it would pretty much give us the same thing. So that's something important to remember about these, that it's not a very precise action, because in the beginning when you create this curve, you're just plotting certain points, and when you connect those points, there's an assumption made that the part of the curve between the 2 points flows the way it actually does, right? And there's a little bit of imprecision in that practice. All right, so now let's move on to something called percentiles. And they're closely related to Q1, Q3, median, everything we've talked about. So percentile or a centile is a measure used in statistics indicating the value below which a given percentage of observations in a group of observations falls. For example, the 20th percentile is the value or score below which 20% of the observations may be found. Okay, so if you say 20th percentile, that means below that mark, 20% of the data can be found. And in contrast, 80% of the observations will be found above that, right? Because if 20% fall below that mark, then 80% will be above it. Another example, the median then, Q2, is the 50th percentile, because we know it is the 50th data point, or we also know 50% of the data falls below and above the median. Example 3, the third quartile, Q3, is the 75th percentile. We know it falls 75% of the way through the data, so it's called the 75th percentile, because 75% of the data falls below it, therefore 25% of the data lies above it. Okay, that's percentiles. So here's a visual example of that. We have a group of people, and here's you, and you are told you are the 4th tallest in this group. So you're the 4th tallest. Here's the tallest, you're the 4th tallest. So that means you are at the 80th percentile, because 80% of people are shorter than you, 20% are taller. You're at the 80th percentile.
Which p% of the data lies. For example, if you say the 80th percentile from that value and below it is 80% of the data. So the first quartile, as we remember, is 25% into the data. So this is also called the 25th percentile. And the third quartile, you might remember, Q3, is at the mark, which is 75% of the way into the data. So this is called the 75th percentile, because 75% of the data is below it and 25 is above. And the median is also known as the second quartile, or Q2, and the median's halfway through. That means 50% of the data will be below it, so it's the 50th percentile. All right, here's the cumulative frequency curve given to you in this problem or in this page. This is for weight data and number of students. So if you look at this curve here, first thing it asks is, the cumulative frequency curve represents weight data collected for blank. How many students? Well, if this curve represents the accumulation of all the data, so you look at the accumulation here, this is the cumulative frequency, and the cumulative total of students would be the upper part here. So if you go to the upper part of the curve and trace it back, that's going to tell you how much total data you have. In this case, it's 250, 260, 270, 280. So our total amount of data is for 280 students. All right, the first question says, how many students weigh 72 kilograms or less? And what percentile is this weight? So we're going to look on the x-axis, which are the weights. We're going to find 72. So 70 is 71, 72 is here. We're going to go up to our curve. You should always use a ruler for this. From there, you're going to go across. When you go across, and you trace it back to here, this is at 120. That tells you that 120 students have a weight of 72 or below. There's 120 students, and above that are the rest of the students, which is 160 more to take us to 280. So 120 students or below have a weight of 72. So that's 120 students have that weight or below it. And to find the percentile, well, we say 120 out of the total 280 students, and we get 0.43. That means 43%, or the 43rd percentile. That means from 72 kilograms or less is 43% of all students, and then above that will be 57% of all students. So this is a 43rd percentile. Now you try this question here. Next one, what is the 85th percentile weight? Now it's giving us a percentile value. So that's not, we don't know what weight it is. We're going to find out what weight it is. So we're going to have to go here. And 85th percentile means 85% of students are below this value. So the total number of students, again, is 280. And we need to find the 85th percentile of that. So we take that percent, 85th percent, and make it a decimal, 0.85. We multiply by the total number of students. That gives us 238. This tells us that 238, which is going to be around here, 238 students is the number at which is the 85th percentile. So we go from there across to our cumulative frequency curve, and then we go down from there, and we find out the weight. And the weight there is 78 and a bit. So that means 78.2, that 85% of students have that weight or below. And here's the 85% of students. And up here, the last little bit of students going up is 15%. So that means 15% have a weight higher than that. So again, 15% is heavier than 78, and 85% is lower than 78. That's the 85th percentile. Okay, so try this one. Okay, last question. What is the first quartile weight? First quartile, as you may remember, is at the 25% mark. So it is the 25th percentile. So first quartile, we're going to use 0.25 for 25th percentile. 0.25 times the total number of students, and we get 70. So the 70th student is going to be the one that marks the quarter of the way through the data. So 70 is here. You go across to your curve, then you go down, and it's right about here. And that is about 69.8. So that tells us that the first quartile weight is 69.8. That means 25% of students are 69.8 kilograms or less, and 75% of students this way are heavier than 69.8. So again, 25% this way, 75% this way. And here 70 represents 25% of students, and then the other 75% of students takes you all the way up to 280. All right, so try finding this one. Great, last question here. We have how many students weigh from 65 to 70 kilograms? So we go from 65 to 70. And we're going to see how many students that is. So that takes us to there. 65 takes us to 20 students. And 70 takes us to 75 students. So that means if you want to find out how many students are between that, from that weight to that weight, it's this number here. So how many are from 20 to 75? You do 75 minus 20, and you find out there's 55 students in between those weights. Because there's 75 lower than that and 20 lower than that, so in between must be 55. All right, try this last question once you're done.
Okay, so let's check your understanding on this. We have a cumulative frequency curve here. And now you will find the lower quartile, median, upper quartile, IQR, the 84th percentile, and finally the question is 35. That means from this data set here, 35 is at what percentile? So for this last one, you will go in the opposite direction. You'll begin on this axis, go up and go over and figure out the percentile. Try it now. Okay, so Q1 we know is the 25th percentile, so 0.25 times this data set, which is 150. Gives us a position of 37.5, and at position 37.5 there, I went down, I got a data value of 31. Okay, next, median. Median we know is 50th percentile, so 0.5 times 150, 75th position in the data set. Here's the 75th position, and that gives me a value of about 41. Next, upper quartile, again, we know that's the 75th percentile, 0.75 times 150, gives us position number 112.5. 112.5 is here about, and then down from there, it tells us our data value must be about 49. Interquartile range then, subtract Q3 minus Q1. Let's see, I think it's going to be 18, yes, 18. All right, 84th percentile, now we say 84th percentile position is 0.84 times the data set, 126th position, which is right here, go down, and therefore our data value is about 53. Finally, 35 is what percentile? Well, we go from 35 here in the data set, 35 from the data set, go up, go across. It tells us it is data point number roughly 48. And 48 out of 150, that's what you have to do now. 48 out of 150 means we are 32%, 0.32 of the way through the data, so we're at the 32nd percentile. Pause if you need to, important stuff there. Okay, one last one to check your understanding, this one here. This curve shows the cumulative frequency for visitors to a shopping mall during a 12-hour period. Here's the 12 hours. You can see in the first hour we had that many visitors. In the next hour we had more, and on and on. And after 12 hours we've accumulated up to 10,000 visitors into this mall. What time after opening does the 30th percentile number of visitors occur? Okay, 30th percentile. Well, it is right here. 30% of 10,000, our total data set is 3,000. We go across, we go down, and it says at hour 6.5. That's when we'll accumulate the 30th percentile. What percentile of visitors is reached 11 hours after opening? So now you're going from hours. Okay, go up from 11 hours, go across to there, and it tells you we're at about 9,500, which means the 95th percentile in this data set of 10,000. Great job, you can do it.